Welcome to the part 4 of this tutorial on generative AI called Key Aspects of Large Language Models. Starting from a few core large language models that we today call foundational models, and last lecture you saw examples of the first of those, GPT-1 and BERT. Today this technology can be accessed in a variety of shapes. So either you can directly access one of the foundation models, or you can access specially trained fine-tuned models that are augmented versions of the foundations models. There's also opportunities actually with a specific technique called RAG to add external documents to the input to your prompt. So this means that you can prompt these systems in a certain way, but then you can also add additional documents that you want the systems to consider. So I think the most important way of accessing LLMs has been not directly, but through an additional interface that we typically call chatbots. And the archetypical chatbot is ChatGPT. However, more and more important is to access these LLMs from other software through what we call APIs, application programming interfaces. And then, of course, there can be many new services built using these APIs, and then you can, as an end user, access the technology via those services. So one distinction here when we look at the resources available today that give us access to this technology, there are either proprietary products or services or free open source products and services. Of course, it's not so simple and binary as that, because there are two aspects to consider. So when you get a software, it's what does it cost you? Do you have to pay for it, or is it free? But then it's also the question is, if you get it, what do you have the right to do with it? You can run it, or you can change it, or you can build on it, and so on. And this is a little blurred, so sometimes this distinction between proprietary. Disclaimer here is that this distinction proprietary and open source is not as binary as one can think. Anyway, proprietary software is software that grants its creator publisher rights and the rights holder partner a legal monopoly of this. And so they have the right to exclude or freely sharing the software or modifying it. So you can basically use it. Also, but if you use proprietary LMS, normally the owner of the software, or the actors that runs this software, also takes responsibilities for all computations. So you don't have to care about computations, because you run the systems through the owners, and you pay for the computations. You pay for the computations via the cost model for getting the software in the first place. So there are many examples of this. So very recent systems. Company Anthropic has a model called Cloud. Google has a model called Gemini. OpenAI latest model GPT-5. Amazon has a system called Bedrock, etc. But there are also Chinese versions here. As you can see, China is moving strongly forward. as a supplier of this kind of tools. On the contrary, then, open source software released under license allow users to use, study, change, and share the software for whatever purpose. Could be also including commercial use, without paying royalties and so on. However, an important disclaimer, really, because some people say, oh, great, we can have open source LLMs, fine, perfect. The problem is that if you do that, then you have to take care of to see to that you have computational resources enough to run the systems you're interested in running. And that's not entirely trivial. It's solvable, but not trivial. So, example of open source free LLMs are Llama. It's a very important example because it's more or less, Llama was exactly more or less the first really high quality LLM that was opened by the company Meta, and where also additional information got leaked, which means that it essentially became one of the systems that people can access and play with. But there are also other examples, and other examples is the new Chinese system DeepSeek. So these open source products you can get access to on platforms like GitHub, Hugging Face, and via licenses like Apache and so on. So if we look just take an example here, if we take the proprietary market as an example, the companies who are offering these products, they normally have a broad range of various foundation and fine-tuned models. They have chatbots, they have APIs, and for all of these there are cost models, so you pay, but on a rather detailed, according to a rather detailed model. So as an example, you can access the OpenAI chatbot by signing up for a ChatGPT account. Simpler versions, simpler models, so you can have for free. Actually, you have to register, but you don't have to pay. But in order to get the later, more advanced models, you have to have a scale, like a premium memberships. And as was said earlier, computations are included. And then in the same way, OpenAI have an API, and you have to apply for that and get a key, and then you also set up your demands. And the computations are arranged, but you pay. And then you could also have local models, so there are, even for the proprietary actors, they have smaller versions that you can download and run on your local computation. But then, of course, you are responsible for your computational resources. One thing that we have touched, it's very important. So I will say a few things about that. That one thing that really made the breakthrough of this kind of technology is that you have a basic retraining, not based on labeled coached material, but on labeled material, large number of unlabeled material. So the systems learn syntax, semantics, real-world knowledge from this unlabeled material. And this gives the model, actually, if done properly, an understanding of language, fact, logic, much like we learn from reading as humans. And there are a lot of sources of material, Common Crawl, Wikipedia, Project Gutenberg, Open Text, and so on. It's also some edited sources that are pre-cleaned, which are easier to use. Many of these other sources need a lot of cleaning, obviously. So the learning here is called self-supervised, means that it doesn't require manually labeled data. So you can have really big unlabeled corpora. Essentially what you do, and what you mean by self-supervised, is that you divide up the material you have. So you take one sequence of what you have, and then you take the bulk of that as the main sentence, and then you train the system to predict a following sentence that exists, but is masked. But then you don't have to take a sequence and the next token. You can also mask random tokens in a sequence and mask them and train on that. Or you can train on pairs of sentences and so on. But more or less, the whole philosophy is you take subsets, you train based on subsets of sequences from the whole material you have, where you mask bits and pieces. So that was that. We go into prompt engineering, as also was said in an earlier lecture. Prompts are important because there are no really strict rules or formalities or syntax for what a prompt can be. Prompt can be virtually anything. Particularly, it gets rather complex when you allow for multimodal inputs. But of course, then what you get out of the system, how good response, how the quality of the generated material depends very much on the form and quality of this prompt. If you really do have a very well thought out exact prompt, then your output is probably more useful than if you have a very fuzzy, vague, abstract prompt. So there has developed an whole field, actually, on top of large language models, with prompt engineering, which is guidelines to teach people how to formulate their prompts in order to get the best results. And there are many techniques, but I mean, an obvious technique is to in a prompt have set up very clear limitations. So you define what you want in terms of a number of parameters, and then you create and then you define limitations for that parameter, saying we want something like that. Then it was also useful to ask the model not only to give you an answer, but to explain the reason behind it, and then could be generalized. So it can be that there are many versions of reasonings, like in a tree of reasoning, and you can also ask the system to compare, validate alternative chains of thought. So if the system reasons like this, it comes to this output. So, you can also give examples in the prompt. So you can say, I want something like this, and give an example, not describe it abstractly. There are also experiments with actually creating programs that generates prompts. So it's a pre-processing. You can say, I want this, and then it feeds into a program, and that generates a prompt that is fed into it. And of course, if you want to prompt with something that is not text, but something else like video or image, then some special strategies may be needed. So that brings up multimodal LLMs. I mean, in the beginning, the systems only handled text, but gradually they developed into systems being able to handle different modalities, both in prompts, content generation. So this means that you can, I think the first systems, you could specify in a text what you wanted, and then you get output, an image, a picture or an image that fulfills the specification you made in text form. That was the first, happened already 5 years ago. But then also later, systems were developed that allowed to include images in the input, in the prompt. And then even a little later, video was a possibility. So you can say, you could still maybe, in the first place, to define as a text what kind of video you want and specify exactly what kind of video you want to see. And then the system produce a video. One of the early systems there was called Sora. Today, there are at least a few systems that can handle these modalities pretty freely. So you can input text. You can input text, you can input image, you can input video, you can output in the same system. So then one can say you have a full multi-modal system. As a consequence, I mean, of course, this is very practical, but these systems, at the point, they reach a point where it becomes virtually impossible to distinguish a real image, video, speech from an artificially generated one. This means that you can actually, you create here a situation with an increased risk for malign creation of deep fakes. And of course, the negative use of deep fakes are generate spam, to automate personal scams. I mean, example, you believe you talk to your son or daughter, but you don't, because the system have mimicked your daughter's or son's voice to the degree that you can't differentiate. It's also, you can add these components in semantic media, in social media, and you can have components that are bullying people, produce hate speech, trolling, and you can also create fake news, news that looks real but is just invented. So there are good things with multimodal systems, but there are also very, very clear dangers, and maybe in this realm is the most urgent and most short-term problems for this kind of systems that I can see. So this is to be continued in part 5, and part 5 goes more into this area of fine-tuning systems. We discussed the pre-training of the foundation models, but then there was a lot of work going on how to fine-tune systems. Thank you.